Hello and welcome to Algebra 2 tutorial. We are still looking at solving quadratic equations. We've done square roots and factoring so far, but now we've got to take sort of a side turn for a second because something happens every once in a while when we're solving these. We get equations that have no solution, where the math just doesn't work out. And we got to take a look at those for just a little bit because there's something we can do with these besides simply writing no solution. So let's take a look at a very simple example of this and then what math does to work around it. So here we have a fairly basic no solution problem. So over here we have a nice graphical representation. So here is the parabola. It obviously has no x-intercepts. So that means there are no solutions. So now let's do that same idea, but let's look at that algebraically. And we can show that there are no solutions algebraically. So again, these solutions are called zeros because we put in 0 for y. Get x by itself, subtract 16 to both sides. So we get x squared is equal to negative 16. Then we square root both sides. And x is equal to plus or minus the square root of negative 16, which kind of blows up. We can't take the square root of a negative number, and so we would stop and we would say no solution. But just like the dinosaurs, math finds a way to get around this. And the way we do that is by thinking in 3 dimensions. So here's that same type of parabola graphed, but this time in 3 dimensions. So our x-axis here, you could think of it as somewhere in here. And if we pull that parabola down in 3 dimensions, it will eventually cross that x-axis and give us x-intercepts and give us solutions. All we have to do is play around with this square root of negative 16 and force that to work. So here's how we do that. First, we split up the 16 times negative 1. The negative 1 is really the issue here, because now I can do the square root of 16. That is the number 4. But we still have this pesky square root of negative 1, which is not something that we can actually do. And so we just say, well, what if you could do it? And you give it a name. And so we give it the letter I for imaginary, which is too bad of a name because it's not imaginary, but it started out that way. But it is a real idea, a very important idea in a lot of higher end mathematics. And so we just take the square root of negative 1 and we call it I. And so our solutions here become x equals plus or minus, because we have 2 solutions, for I. And we call that good. Right there is our solution. Now you might be thinking, man, it does sound like you just made that up. So let's check it algebraically to see if it works. So if I plug this number in, this should work algebraically. So 0 equals, I'm going to plug in my answer, x squared plus 16. And so if I plug in this solution, one of these, either positive 4i or negative 4i, this should be true. So let's start with 4i. So 4 squared is 16. But what is I squared? Well, I squared would be the square root of negative 1 squared. And the square root and the square then cancel out. And so you're left with I squared being equal to negative 1. All right, just following the rules of math there. So if I square I, we get negative 1. plus 16 is equal to 0. And hopefully that is now looking like a true statement. 16 times negative 1 is negative 16 plus 16, and it does equal 0 there. So it looks like this weird answer of 4i does actually work algebraically. So that's how we get around the issue of negative square roots. We introduced this new idea of an imaginary number, I. All right, that's a little weird, so let's try it one more time. So we want to find the solution to this quadratic equation, which means we put in 0 for y, and then we solve for x. So let's see here. First we're going to subtract 32, subtract 32, that goes away. Negative 32 is equal to 8x squared. Divide both sides by 8, so you get x squared is equal to 32 divided by 8 is 4. So where are we here? Yeah, negative 4, sorry. That's what was getting me an issue there. Negative 4. Square root both sides. And so x, I'm going to write it up here where I've got a little more room, is equal to, so we can't square root negative 4, and so we break that up into square root of 4 times negative 1. Eventually you can do this step in your head, and the square root of 4 is 2, and the square root of negative 1 is I. Oh, I almost forgot. We have to do plus or minus to get our two solutions. So that is the answer. Let's check that just to make sure we didn't make any mistakes. So last time I did the positive, let's do the negative this time and see if that one works as well. So when I check this answer, 0 is in for y, 8x squared plus 32. So when I plug in one of my answers here, we're going to do negative 2i this time. This should still work out and equal 0. So let's do this. We have our 8 times. So what does this become when we square it? Well, negative 2 squared is positive 4. And I squared is negative 1 plus 32. All right, so 4 times negative 1 is negative 4. Negative 4 times 8 is negative 32. Plus 32 again gives us 0, and that is definitely true. So it looks like our answer is correct. You could also check that with the positive 2i if you wanted to, but the math is almost exactly the same. Alright, so there we have a quick look at imaginary numbers. They help us fix quadratic equations that have no solution. In order to make them, to force them to work, we use these imaginary numbers, the letter I. So let me give you one here to try out, or two of them here. See if you can do those, and make sure you check your answer at the end by plugging your solutions in. The more practice you have working with I, the better. Good luck.